Z-score that goes into the rejection region, if it's less than negative 1.645, we're going to reject the null. And if it's over here, we're going to accept it. Okay. Number 5 is that we get our standardized test statistic. So find the standardized test statistic. This is basically the math we're going to do to compare it to the rejection region. So there's a z-score. You're going to use x bar minus mu over sigma divided by the square root of n. That's what I meant to write down here, and I wrote up there by accident. So I'm going to use that formula to kind of find out where this company compares to our rejection region and whether or not I'm going to accept or reject the null or claim. So for 5, I'm going to do x bar minus mu divided by sigma divided by the square root of n. X bar is the sample mean that they got right here. That is 66,900 minus the mu, which is 6,800. Or 68,000. So 66,900 minus 68,000. Over our population standard deviation, 5,500 divided by the square root of 20, which is n. When you put this in your calculator, make sure that you have parentheses around the top and the bottom. I got a z-score of negative 0.89. So this is our test statistic right here. All right, by the way, I meant to have 7 steps, so we're adding a step 7 down here. Step 6 is to reject or accept the null hypothesis. You always consider the null first. And if you want to know why, it's just because all statisticians are trying to do hypothesis testing in the exact same way as each other, so they always consider the null first and then make a decision about the claim. So the second thing you're going to do is reject or accept the claim, and sometimes the claim is the null and sometimes the claim isn't. Over here on the remember side, you reject if it's in the rejection region. And when I say it, I mean whatever number you got for number 5. And then 7 is write a sentence in context. Kind of about like what your conclusion is. Pause if you need to. Okay, going back to my example for number 6. So I got a z-score of negative 0.89. So here is a z-score of 0 right in the middle. Here's negative 1.645. So maybe negative 0.89 is hitting like right about here. Negative 0.89. Now, that does not fall in the rejection region. It falls in the null, so I'm going to accept the null. In step 7, I have to decide what that means about my claim. So in this case, I'm accepting this. I'm accepting that their salaries for this company could be equal to or greater than 68,000. Because it's just not far enough away from 68,000 to make me believe that the whole population has to be less than that the mean has to be less than that. And since I accepted this one, I'm rejecting that one. So I'm going to reject the claim that, and this is the part where I have to write a sentence, the employees make less than $68,000. on average. And that's it for example 1. Okay, so now what you're going to try to do is you are going to try to do example 2. If you feel lost at this point and you just want to do example 2 with me, you can, or you can stop the video and try example 2 yourself by following the steps. I'm going to go ahead and do it right now, so if you need to pause, hurry up and pause, because I'm not gonna. All right, step 1. I'm not even going to look at my directions because I know what my directions are. The first direction is to check and see if the population standard deviation is listed. It is. It's right here. It even says population in it. I might as well read the question. It says that the researcher claims that the mean annual cost of raising a child that is 2 and under by a husband-wife family in the U.S. is $13,900. That means it's going to cost you this much per year just to have a baby. In a random sample of husband-wife families in the U.S., the mean annual cost of raising a child is $13,725. Okay, so they did a study. They found that their mean annual cost was this, and they're comparing it to the claim, which is this. And they're saying that it has to be that. So the question is this close enough to say that they could be right? The sample has 500 children in it, so they've got a pretty big sample here. It doesn't say that the sample's normal, but N is definitely bigger than or equal to 30, so we're good there. Step 2, H sub O, H sub A. All right, they're claiming, excuse me, that the mean is equal to that. So that must be the H sub O. The mean is equal to is always in the H sub O. So this time the claim is the H sub O, not the H sub A. The H sub A is the opposite, which is 13,900. Not equal to. 3, it says that the alpha, we're willing to make a 10% mistake here, is 10% here. Is there enough evidence to reject the claim? Okay, so we know that alpha is 0.1. We also know this is going to be a two-tailed test if you look at your notes from yesterday, because anything that has an equals to it is a two-tailed test. I'm going to draw a picture. Here's my H sub O. Over here is my rejection region on this side, my rejection region on this side. It could be too low, it could be too high. I don't really know what it is yet right now. We're hoping for the claim that it falls somewhere in this region and not in the rejection regions. This was step 4. We have to figure out what these edges are. Now, if it's 10%, if the alpha is 10% in the tails, these are our errors, they add up to 10%. That means that this side would be 5% and this side would also be 5%, which is confusing, I know. And I really don't need to look up what it would be over here because I just did this on my last problem. I also did 5%. So this one has to be negative 1.645 and this one's positive 1.645. And if it falls below negative 1.645 or above positive 1.645, then I'm going to reject that null.